school senior from Connecticut and a wiring and controls team member of FRC Team 236, the Technotics. Our Hall of Fame team diligently brainstorms, designs, prototypes, creates, and tests robots to compete in the first robotics competition each year. After thoroughly examining this year's game and possible scoring techniques, our team found it important to have a precise, functional gear placement mechanism. This is especially important during autonomous mode, where a team can score 60 points in the first 15 seconds of the match for placing a gear on a lift, having a human player place the gear in a rotor, and turning it. With this in mind, we got to work researching, designing, building, and testing a gear placement device that would allow our robot to receive a gear from up above, bring it to the front of the robot, and hold the gear in place long enough for it to be placed up on the airship lift. This design has undergone many changes throughout the building season. Originally, the gear placement device wasn't going to move at all, and it would sit on the front of the robot as a slot to catch and hold gears. However, this was ineffective since gears could fall into the slot in a myriad of positions. It left the possibility of the gear colliding with the lift instead of being placed on it. The gear placement device uses a garage door motor to move a tray from the top of the robot to the front in order to retrieve gears from the loading station and to place gears on the lift. Mounted on the tray are movable arms that open and close to orient the gear for easier placement. When the tray is in the up position, the arms aim toward the back of the robot so the gear doesn't fall into the fuel chute. When the tray is in the down position, the arms move to form a funnel so the gear doesn't fall forwards off of the robot. Once the gear is securely on the pin, the arms open up again and the gear is released. The garage door and arms use pneumatics to open and close. Limit switches are used to ensure the tray doesn't move too far in the up and down positions, since this could damage the robot. In addition to this, a camera is mounted near the device so drivers can easily see where the gear is in relation to the lift. Without teamwork, the robot would not be able to function. Team 236 is divided into multiple subgroups that manage the creation of a certain part of the robot. Each team contains a few students, as well as an adult mentor, to ensure the students stay on task and stay safe. This build season, we had teams for fuel intake, the climbing mechanism, the fuel shooter, gear placement, the chassis frame, wiring and controls, which I was on, programming, and social media. In addition to having different teams during the build season, we also divide into groups during competition events. While a small group of students drive the robot, another group is responsible for scouting robots on other teams. We record data on what functions other robots have and how they perform during matches. Overall, the process of creating a robot is much simpler when broken down into smaller pieces. During the build season, we have teams communicate with each other often to ensure the robot has enough space to implement each team's device and to make sure projects don't interfere with each other. Even new team members are encouraged to aid in brainstorming and building the robot. Members of different build teams can communicate at any time to share files, questions, suggestions, or information via email, Remind, Google Drive, or Chief Delphi. Our team creates and distributes new shirts each year, one shirt per team member at the very least. This year, the shirts state our team number, nickname, the names of each team member, and more. At competitions, we hand out buttons with our team number and logo to other teams. Throughout the year, our team holds various community events to raise awareness of FIRST events. Just this season, we have hosted a Bash at the Beach mock game event, Lego League competitions, a Lions Club pancake breakfast, and we have invited a Boy Scout troop to learn about the making of a robot. We believe community involvement can make a positive impact on the members in our community. Being part of the team has taught me the value of collaboration, clear communication, and perseverance, as well as giving me experience in engineering. Along with my classmates, I've spent countless hours after school and on weekends to build this year's robot. And finally, over the time I've spent on the team, I've learned that being part of FIRST is the hardest fun I'll ever have, and I love every second of it.
3, 2, 1, go!